Alright guys, this is unit number 7, lesson 6, and this is the last lesson of this unit. So today we're going to be doing more work with factoring trinomials, and not just trinomials, but factoring everything. And you'll see next unit there's a lot of practical applications to factoring, so we really have to get it down. So we're going to do our last part, which is what we call factor completely, or complete factoring. So we're going to do a couple extra steps today. So if we look at this first trinomial here, if I asked you to factor this, you'd kind of whine and complain because this is the hard one where we have a GCF, or excuse me, a leading coefficient greater than 1, and therefore it makes it more difficult. Well, what we're going to teach you now is that when you factor, you should always check for GCFs first. See if that will help out. So what you want you to do is part A is factor this by GCF only. So do that for part A and hit pause and try that now. Alright, how did you do? Well, hopefully you came up with the GCF was 4, because 4 goes into each of these terms. They both don't have x. Then you should know what you're going to do is you're going to write out the polynomial, whatever it is, divide it by the GCF. Then remember to put your GCF out front, and then just what do you get left over? So this is factoring by GCF. Now, if you notice what's left over is still a trinomial, and this thing could probably be factored again. So factoring completely means just to keep factoring it. So now ignore the 4 and could we factor this? So what you're going to do is rewrite it over here. And now just try to factor this piece alone. So see if you can do that. Hopefully it should be easy for you. So hit pause and try that now. Alright, so hopefully you did something like this. So now this one, some of you guys might have said, oh, I'll use 6 and 1 because 6 minus 1 is 5. But remember, we're multiplying to get to a positive number. So be careful, even though negative 1 and, whoops, try that again. So what I was trying to say is negative 1 plus 6 makes the 5, but when you multiply these, does it get that positive 6? So be careful. So we want a plus 2 and a plus 3. When those multiply, we know they make the 6. So hopefully you did that all right, and you got something like this. So there's that trinomial. Now what you have to be careful is that this is just the factors of these. You still have to include 4 as a factor, so we have to write that in there. Now this is factored completely. You've taken everything out. Now if we look at the very original trinomial we started with, before today, if I gave you this, you probably would have tried to factor it like the hard way we did yesterday. And if you did, you'd get maybe something like this. This would work if you look. 4x times x is 4x squared. 4x times 3 is 12x. And here would make 8x, and 12x and 8x makes the 20x. And this also makes the 24. So this works too. But if you look in this binomial, there's a GCF in there, and you'd be able to factor that out. So if you left your answer like this is not factored completely. This is just factored. If I say factor something completely, and if I give you 12, and you say, well, 2 times 6, well, that's not factored completely. Factored completely is you could factor to 6 more, and the factor completely would be 2 times 2 times 3. That is 12 factored completely. So hopefully you understand the difference here. This one wouldn't work. You'd actually get this wrong if you left it like that. So we keep working with these and see how you do with them. And it's pretty much what I was saying down here is whenever we factor, we should always look for greatest common factor first. Always do that. It will make things much easier if you take out the GCF first. You could do it second here, but you know that this type of factoring is harder than this type of factoring here. Alright, so let's keep going and see how you do. So I'll give you a couple, show you a couple, and then you could do some. So I'll work with you on part A, and then why don't you do the rest. So when you look at these, always check for GCF first. Hopefully you see that a 5 could go in there. So I look for that. Okay, there's my GCF. So now I should know to divide each by the GCF. Put the GCF out front, and then just do my GCF factoring by dividing. Now after you do the GCF, look at what's left and say, can I factor this? And you should know. This is actually a really easy one. I would not do like the second process where you have to go through. Since there's only one factor of 2, I think I have them. I guess I don't. There's only one factors of 2 and one factors of 2, so there's not a lot of options for the guess and check. So this is the one where I might not I just do it this way. So I would think, okay, this times this, and all I could do is 2 and 1, and I want to try to get 3. So if I did this as 2, this becomes positive 4x, and this, if I put 1 in here, this becomes 1x, and I want to get positive 3, so I'd subtract that, and I would add that, and I could see that now everything works out. You could factor any way you want, but when there's just a few factors of this term and this term, the guess and check might be a little faster. Either way, it's fine. Okay, now I shouldn't have circled that though. That was bad of me, because the GCF, remember, has to go back out front. So don't forget that 5 when you're done. A lot of times you do all this hard work and you forget to put that there, and then you're going to get it wrong. So go ahead and try B. Do it on your own. Just look for GCF first, factor it out, and then see if the leftover, whatever the polynomial is, can it be factored again. So give that a try. Okay, how'd you do? Did you come up with a GCF of 3x this time? And then you divided everything out. And when you did, hopefully you came up with something like this. And you can see that this trinomial is actually factorable. You've never factored one with x to the 3rd power, so that should have gave you a hint that you couldn't just immediately do this type of thing. Oops, oh well. Now, let's factor the 12. So the factors of 12, there you go. And I'm trying to get negative 7. But since the signs are the same, there we go. I know I still have to add them, but now if I did a negative 3 minus 4, that makes the negative 7. So those would work right there. And there's my answer for factored completely. All right, so we're going to just keep working with those, and I think you'll do okay. So why don't you do C and D on your own? So you hit pause and only hit play once you have an answer. All right, for C, did you get GCF of 7? Divide everything by 7. Do your GCF work here. Now I got to factor this, so I'm looking for factors of 10. That subtract to get to the 3. So be careful with your signs. I want to get a positive 3, so I'd do negative 2 plus 5. There we go. And now I could keep factoring. And there's our answer. Okay, for part D, what was our GCF? 2 on this one. Divide, rewrite. Don't forget that 2 out front. And again, even though this has a leading coefficient of 3, there's only factors of 2 is just 2 and 1. So I didn't even have to do a lot of work for that. So again, I might just do a quick guess and check. I might do something like here and here. I'm trying to get negative 1. So it looks like if I did a 3 here, that would make, oh, sorry, totally wrong. See, I'm just trying it out. So I think I want to get 3 here, obviously, and I want to get 2 here, and that would make the 1. So I have to do 3 times 1 and 2 times 1, and I want to get a negative 1, so that should be negative 1 there, positive there. So this goes here, and that goes there. All right, and hopefully I did that okay. Let me know if I made a mistake somewhere, but I think that was good. Okay, let's keep going. I know, this is pretty fun, right? All right, so now it said factoring trinomials, but we could actually work with binomials too. So we want to factor these completely. All right, so what we're doing this is we're going to factor these completely. So again, the first thing you should do anytime it says factor is always look for GCF. So looking at this, hopefully you see that there's definitely a GCF. 2 goes into both of those, so there's our GCF of 2. Then I'm going to divide this by 2, put my GCF on front, and if you look at my leftover, this is a binomial. I could take the square of this, and I could take the square of this, and there's a difference. So you should recognize that right away as a dots factoring. Difference of 2 squares. So then you just take the square root of that, which would be x. Take the square root of the 9, not the negative 9, but just the 9. And then you should know it now it's just going to be x plus 3, x minus 3. So we did that factoring a little while ago. So remember, this comes from here, and we can't forget the 2 out in front. So now it is factored completely. All right, so go ahead and give B a try. So hit pause and try that now. All right, so let's see what you did. So hopefully you got GCF of 5x. Divide everything by 5x. Put that out in front. Do your division. That's pretty easy. Now, you don't have to be required to show this step here. A lot of you guys could do that in your head. So then you could just end up with x plus 2, x minus 2. And don't forget your GCF, and there you go. All right, let's keep going. So, okay. So on this one, it just wants to try to show you some shortcuts. That's all this really is. So we got this trinomial here, and it says, do these three terms right here, do they have a GCF? So just answer that quickly, yes or no. Hopefully what you realize that nothing goes into 11 and 2 and 12. So there is no GCF. I think it's right somewhere in there. There it is. Okay. So now this is a very interesting question. Let's see if you can answer this. If you can, you're going to really catch on to factoring pretty good. So I like this question. So what he's saying is, hey, could these two be a good guess to be the factor of this? Could these be the factor, and could these be the factor? So, and like obviously quick, you could see that 2x times x makes the 2, and the 2 times the 6 makes the 12. So it seems like a good guess. But so why would these guesses not make sense? So even though on paper they look kind of good, okay, 2 and 2 and 12 and 12, 2 and 2 and 12 and 12, but why, there's something wrong with these, and it involves your, and I shouldn't give you this hint, but why not? It involves your answer to part A. So write something out to see if you could get it. All right, what did you notice? Did you notice that we said, hey, there is no GCF in this problem? But if you look at these individual binomials, is there a GCF right here? There is. You could factor a 2 out of this. You could factor a GCF out of this, and you could factor a GCF out of that. So when you would do that, you'd have a little 2 out here saying there's a GCF on the entire problem. So kind of clever way to eliminate some of these. So here's what he wrote. There's no GCF, so the individual binomials can't have a GCF. So hit pause and fill that in if you need to. So in here, if a trinomial does not have a GCF, we're just going to fill these in, then neither of its binomial factors have a GCF. So since we said this doesn't have a GCF, then none of the factors can have a GCF. So with that, we could actually try to factor this by doing some guess and check, but eliminating some of ours. All right, so when we go to factor this, we already have the factors kind of up here. Now, what I might do is, well, what if I swapped these? Well, that would put a 6 here and a 2 here, and that would still make a GCF. So no matter what, these would never work. If I swapped these two and put the 3 and the 4, there would be no GCF in either of those. And if I swapped this and put the 1 and the 12, so already I could just try those. So 2x plus 3 and x plus 4. Let's just see if that works. That makes 8. That makes 3. And I want to get 11. That looks pretty good if I do plus and plus. So there we go. So you can kind of eliminate some of the factors and therefore just have less to try, and it makes things a little easier. I want to show you that in this last one right here. So this says use smart guess tips to factor this out. So this one would be tough because there's a lot of factors here and a lot of factors there. So I have to speed this up a little, but there's the factors of the first term and there's the factors of the last term. Now if I try to use the 2 and the 2 as my front x and x, well then I couldn't automatically use any of these because these have even numbers and that would cause a GCF. So I'll show you what I'm talking about way over here. These are all the possible different pairs of binomials that could possibly work. See, that's a lot of guessing and checking. But what I was trying to say is with the 2 and the 2 here, if there's another even number, then I could always take a GCF out. Since both of these are even, and each of these have an even number, if I paired these up, I'd always be able to pull a GCF out. Notice I could pull a GCF there, 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 and there. So none of these could work since this doesn't have a greatest common factor. So I could cancel out trying those. And over here, that has a GCF, GCF. What else we got? And here's a GCF. So I can't try this, this, or this. So now I just have some of these to mess with, and it makes my thing a lot easier to guess. And obviously that's going to be way too big if I try that one. And I'm running out of time. Let's see if I can do it fast. I'm not sure if I'll make it in time. Let's see, that would be 8, negative 8. We want 21. So 24 and 3, there's our winner right there. All right, So we'll give this a try in class tomorrow.